Welcome, everybody. This is distribution demo for the 15th of December in 2022. That might be the 16th for some of you. Today, we're going to look at something interesting. We had a customer report of ephemeral disk actually causing some pods to get kicked. What's interesting is verbatim from their kubelet logs was that a pod got kicked for using less than 1 meg of ephemeral disk, but that's because it only asked for 0. So their cluster happens to have very strict behaviors configured, right? And we actually don't ship ephemeral requests or limits out of the box as a part of the chart. It's not that you can't configure them. That's totally doable. It's that we just don't have it pre-built as defaults as part of the chart. This customer in particular was trying to run a backup, and every time the cron job would fire, it would get part of the way through and then stop, and then part of the way through and then stop. As you can imagine, why do my backups always fail? Because the container keeps getting killed. Then, wait, why? Now, this particular customer isn't actually having the pod fail because the pod is failing. It's failing because the pod didn't ask for any resources, because none was asked for. It got 0. So when it was using more than 0, it was first on the list. Oh, right. So how do we hunt this down? What do we look at in figuring out how much is actually used in terms of ephemeral? How do we find where that's coming from and things like that? So the first question for everybody is, what is ephemeral storage in case? Like, what is it? So if I do a quick share that screen here, as always, if it starts to flicker, tell me, because, screen sharing. We care specifically about the ephemeral resources. We're familiar with CPU and memory, even huge spaces, but what about actual ephemeral storage? Right now, this matters more because 1.25 made this officially stable, which means a lot of people started just starting the knobs and then finding out, oh, hey, stuff gets weird. Ephemeral storage is effectively whatever you would do that is scratch space within your container consumption. If you're writing anything, if you're doing logs, if you're changing a config file, if you're using some scratch space somewhere, right? Now, what I do want to call out is some of us are aware that we make use of empty dir but memory, aka tempfs, for a number of things for handling data in between the init containers and the running containers. Those do not count as disk, as ephemeral storage, because they're in memory. That does mean that they apply to the memory requirements of the pod, but they don't count for that. They legitimately count for the ephemeral disk, legitimately counts for anything that you would write that doesn't go to a PVC. It doesn't go to a memory tempfs, right? So the most common offender that we're going to know about is logs. Logs, right? Biggest complaint that we have is we write log files and then we have to turn around and cat them back out with JSON logging with GitLab Logger or something like this. That's an offender, and we've had customers ask us to make arrangements to make that work, and we have. But that doesn't account for what this customer had failed. So the question is, how did it actually use disk? Why did it use that disk? And what caused it to push across the limit that triggered something, right? Now, what matters here is we have the ability to set resources limits and resources requests, including ephemeral storage, all right? Our chart, for every container, we already have a resources that's empty when it comes to the map. We don't have a hard structure set in this behavior, so you can actually supply this additional configuration for any of our charts. You just have to know that you can do it. We don't have it in our documentation, but because we take the resources map and directly to YAML that, It'll work just fine. So let's have a look at what this actually looks like in terms of where the storage gets used and how can we manage to hunt that down. So I'm going to see if I have an existing deployment right now. That cluster does indeed have a deployment of 662, which is good. All right. So I'm going to open myself another one and run K9S. Now they're trying to do this and their cron job is getting whacked. So, maybe that's not quite what I want. So let me see if I can go into one here. I'm going to grab this guy here. I'm going to grab my toolbox container. Now I have a quick script here that will reach in through the raw API in Kubelet and actually find out how much ephemeral storage is being used by a given pod. So I'm going to run pod ephemeral here and ask Kates how much ephemeral storage is being consumed by Toolbox. Well, the nodes available for allowed capacity here is that, total capacity is there, and the used bytes is 147,456 for Toolbox. Not much, right? Now, I'm going to look at the same thing for one of the web service pods. Wait, what? Let's see here. That's 3 digits, and that's 3 digits, and that's another 3 digits. So we're easily into the megabytes here. We're talking about 105 megabytes in a web service container. And a toolbox, which basically hasn't done anything, is 147K. Interesting. Okay. Web service is making logs, right? So root control exec ti pod c web service, and we're going to use du. Let's say hd1 var log GitLab. 37 megs out of the 105, 106 ephemeral used by the container is logs. Well, that's a lot that's not logs, right? We're talking 70 megs plus that's ephemeral in the container. What is going on there? So let's go ahead into the toolbox container here. We know this one's got basically nothing running most of the time, right? And it says it's only got 147. So if I go back to the toolbox, okay, nothing has changed. I'm gonna do let's do GitLab Rails console. Now we know this takes a little while, right? The nature of I'm going to spin up the Rails behavior to get into that so that I can get the console so I can run some commands and check the state of the machine as an application, its memory and database, right? Well, used bytes 147. Nothing seems to have changed yet. Rails is still booting though, so probably just a busy bee. All right, now it's booted. Okay, 147. For being booted in 32.59 seconds, it's still not giving me a shell yet, so we're getting there. Wait, what happened? We finally get to an actual shell, and used bytes went from 147K to 58 megs. All right. So if I do a quit, now I'm going to make this easy to find. But who here is familiar with how the container layering systems work for runtimes? So when you have a Docker container and you're going to execute it, you need a scratch file system because you can't write to a tarball, right? Anybody familiar with how that works from the driver system inside of Linux? Nope. All right, so we're going to dive on that. Effectively, it does literally layer the file system. Okay, so you have a driver that is configured by either your containerd, your runc, your Docker, etc. These days, by default, that uses one called overlay or overlay 2. And effectively, what you end up having is a stack of things together, and then the last one is what is the difference between the running system and all of the things below that are merged together. The easy way to deal with this is collect a few pieces of information. One, you need to know the node that that particular container is running on, because if you don't know the node, it's really hard to find where its file system is, right? So I'm going to grab the pod and go control get pod, go YAML on the pod name, and I want the metadata. All right. That's indeed the right one. Good. So I'm actually just going to go and get the entire data because it's somewhere in status and I can't remember where it's at. No, it's not in status. Where do we hide this in the YAML, folks? There should be metadata in here and tell me which node it's on, and I'm not seeing it for whatever reason. Oh, there it is. Under spec node name. All right, so that's the node I care about. So I'm going to do gcloud compute ssh dirt zone us 1. I think that's where my cluster is. Control get node at YAML. Pretty readable. Central 1B. I need to learn how to type that up. Is that dash 1B? I know I just read it, but you know how it goes. It's 1 dash B. I'm going to pop into this node. Now, this is running Google's Container Optimized OS. So really what you care about in this particular case is literally what they call toolbox. It's in their bin path. And what it will do is it will pull down and mount in a whole bunch of stuff. So you can do debugging stuff, install packages, things like that. So I can actually do things like strace and hunt around in the file system and things like that. Now in the container back over here, I'm going to go to my home directory and I'm going to make myself a file that I can easily find. And while this starts, we now know that there is a file named bogus that I can literally do find for the file named bogus, right? I highly doubt that there's any other pod or file or anything that's got a bogus name in here, literally. So as soon as this starts, I'm going to do find / type f name bogus. I'm going to let file system do its thing. It's going to take a minute. And it's going to find multiple entries. The question is, which one do we care about? We actually care about this one right here, this diff. If I do cd and I take off everything down to the diff, that's a really long PS. All right. Let's see. Echo PS1. We'll worry about fixing that later. Okay. So if I do find here, huh, a bunch of stuff. Let's see if we can make that easier to read. I'm gonna do du-hd2. So we've got some Prometheus data, which isn't entirely unsurprising. We've got a little tiny bit of data in temp. Serve GitLab is 56 megs. All right. And etc. We have PKI, which is 16K, and GitLab, which is not a lot. Now, if we look up here, we can see that's our CA behaviors. And this is our etc. GitLab. We touched anything in there. And then we have our home get S3 config, bash history. Bash history is here because we've run commands. S3 config is here because we generate a template and it places the file here. And bogus is the file that we made. Shell secret is transplanted. And then here's the other stuff that we template into the config directory, right? Now, if I do hd1 serve GitLab, not slash, just serve GitLab. Our config is 32K, which is all of our templates. 56 megs is boot snap. Hmm. We pre-compile boot snap. Why did boot snap generate a whole bunch more files? Well, that's kind of the nature of what boot snap is. It kind of tells us also why it took 39 seconds plus the time it took to get to the Rails console, and then there's where the delay came from between it's booted and here's your shell. Right? Now, the question is, what is the difference between what we did and this here? Because I see 56 megs in boot snap that got changed. I see the total is only about 56 megs of the total usage. But how much did we end up seeing? Right? What was our ephemeral usage? Does anybody remember? It's about 58 megs. So we haven't necessarily accounted for every last piece, but most of it is actually right here. Now, if I leave the toolbox container and I go to web service, right? It's another Rails-based container. And I go odd ephemeral on that, right? We have 106 used, right? So I'm going to go into this guy. Are these on the same one? Oh, good. They're even on the same node. Perfect. So control deck PI into that pod. Whoops. Web service bin bash. Data home. And I'm going to touch web service was here. Now, I can do that same find slash type f name, right? I am, however, going to take that slash and just expand that a little bit because we know that the path we care about is somewhere buried under the overlay 2 driver. Should take less time to find, basically. Okay, now we know the directory we want to get into. So now I can cd to that diff directory. Now if I do du hd1, 56 megs. Where's the rest? definitely in the web service container because there's my file. But where's the other giant chunk, right? If we got 56 here, and it says we've got hundreds, where is it? We've got twice as much. Where did the rest go? Also, where are the logs? Like, there is no var contents here. We know it's writing logs, don't we? UHD1. Yeah, it's 37 megs. Still, 56 plus 37 is 90 something, right? That's still a significant chunk of not accounted for. We still have to figure that much out. Now, if I can do a describe on this pod, we'll go down and look at the volumes. We got the sets research. We got the shared upload directory, which is an empty here. Now, you'll notice there's no medium set. There's memory, a memory, a blank. That right there, my friends, is actual scratch disk because it's not marked as that kind. So if the reason we don't see the log files is because they don't exist in this same place because they're not technically on the file system of the container. They're technically on a different file system, right? So why don't I go back over here? Only problem is, hey, well, how do I find where this is? Guess what? Touch ws log. This is still the simplest way I know how to tell you to find these things. Now, I don't know exactly where this is actually at, so I'm going to do a type F name on that, and I'm going to do it on the root directory just to find out where it is. Okay, so now instead of being in overlay 2, we're now actually in volumes, right? Because we're using a Docker volume. Now, my cluster, I say that because my cluster is currently running 1.2.1. It is badly in need of an update. So it hasn't been fully converted to containerd. But in the end, that doesn't matter because it still uses overlay 2 as well. So if I pop over to where this wants to be, right, there's just data. So data, LSLA. Okay. There's all of our logs. DU HD1. Well, there's that chunk, right? Now, we're still in a situation where we know where 56 of it is, and it's all Bootsnap cache, which, by the way, tells us we need to do something because it's regenerating the Bootsnap cache at startup. So we're losing time, right? That's an observation. Which explains why if you give that node ephemeral storage and NVMe, it boots faster because it's trying to write to disk. You have, say, ST1 slow disks, she gonna be chunky, right? Now the question is, where is the rest of it? Still needs to be found, but what can we otherwise identify? Good question, right? Let's see. Mount. Now, we don't happen to care about anything on the C group patterns. Nothing here matters. We have etc GitLab. There's SSL certs. And then we have a couple of mounts for var opt and var GitLab templates. There's the config secrets. There's our extracted hem. Glitch temp. I guess we could see how much junk is in there. Well, there's nothing in there, is there? And then all the rest of them are procs. So in terms of what our container we expect to write, I don't really see anything else consuming a big chunk of memory, and I don't know exactly where it's coming from yet. Now, in the sake of time, I'm not going to spend too much more time diving into that particular behavior. The concept that I wanted to convey was how can you hunt this down? Where is your consumption coming from? How can you find it in its real usage, right? If you're using a volume or you're writing a content to a volume, whether it's ephemeral or a PVC, it won't show up in that diff layer from the overlay driver. If you're using it from a mounted position like we do with the logs, it's ephemeral, but it shows up in a different location because it's technically a volume that we have defined. So the technique of literally write some file, go hunt for it, is the important bit. So there's that. Now, I'm going to hit stop share for a second. This becomes the interesting one. Why do we use so much ephemeral? Do we take that into account? How do we take that into account? We know that Rails, because we Ruby and Rails, because we make use of Bootstrap, are it's possible that they rebuild the Bootstrap cache, right? And to be honest, rebuilding the Bootstrap cache is better than building the Bootstrap cache from scratch. But we do want to optimize it so it rebuilds it far less often, if possible. Like, what triggers it to do it? What can we do to reduce the likelihood that it does it? Right? That one, we're going to need help from engineers throughout the company to figure out what's going on and why and how and what we can do to minimize the impact. When it comes to the outputs of the templates on the file system, we know this, we expect it, right? There's not a lot we can actually do, right? We could, in theory, mount some directories and define volumes, and we'd still be consuming ephemeral, but mounting things to slash etc. and basically kissing etc. goodbye is not a great idea. Problematic to say the least. And there are proponents out there in the wider system that will say, well, just never write anything to the file system. That's not technically possible with our application. Sorry. I can do some real expensive engineering to make it look like I never write it to the file system, but I'm going to end up writing it to the because that's where the application loads the data from. And I don't have control over that. And it would take a significant amount of engineering to rewrite Sidekick to read its configuration from a different location. Same with Rails. So, can't get around that one. Sure, a couple of applications we have could theoretically pull almost everything from the environment, but exposing everything through the environment is not necessarily what you want to do from a proper behavior. I'm aware of the 12 factor. I'm also conscious of the fact that environment variables can be scoped in many ways. And having to get into the file system of the running container that you're degrouped away from is not the same thing as having to just, hey, can I get the environment for that process? Depending on which tools and runtimes and appropriate security controls and other things that are in play. You'd be amazed what the APIs will let you do. So at this point, circling back for a second, we know that Ruby and Rails are going to be expensive when they regenerate boot snap. We know that there's going to be template outputs, and we know there's going to be logs. And some of the things are far larger offenders than others when it comes to logs or generating more logs than needed as well, right? What actions do we have the ability to actually take from this? One, we can try to find out why Bootsnap cache is being rebuilt and thus rewritten to the file system. And two, we can do our best to identify and isolate any of those instances. Three is actually add the ephemeral storage requirement that we know it's going to need so that at least we ask for it. Even if we don't set a limit, that we at least request it for those clusters that are now in 125 where this is a stable pattern. Now, the good news is it's really simple to observe. Stand it up, check everything after a couple of minutes, and then go find what's generating logs for other disk access and where and why. Now, the good news is we know where logs go, right? There, that's simple. But now we have to identify which pods are using ephemeral storage just because they booted a process, right? I don't expect Italy to be using that much, but it may be, and we need to know. I don't expect mailroom to be using that much, but it may be, and we need to know. Especially when we're talking about some things like the temp folder that's used to share content between Workhorse, Puma. That one's going to be fun. My headset battery died. Good news is it's very hot swap. So 1 second. There we go. I can hear y'all again. Now, for the sake of doing that work, we may be able to most easily detect that by actually using Docker Compose and on our individual machines running the same basic commands of hop into it, write something to its diff layer, and go find it. And then go into that diff layer and see where the files are being written. We can use local Docker commands to get information about the volumes that are used to share data between containers. And we can examine the file systems of the individual containers to detect those things that are being written somewhere and collect that information. We can't do anything about the temp folder because that's uploads, right? User uploads, we have no idea how much they're going to use. And if your container dies because somebody uploaded a 1 gig file, it's going to be a weird and hard to isolate failure. Like the user will get a really weird error back. The logs will show that the pod was terminated because of ephemeral disk storage, but now you're going to have to figure out how the correlation ID resulted in the origin of the event of that pod being killed due to ephemeral disk. That'd be a fun one to hunt down. Like I can conceptually trace it, but good luck for somebody who doesn't know what to look for because of the environment and platform. I feel for a customer that has to try and trace that down. And I feel for support who gets the call of, hey, every time our users upload this one massive artifact, half our fleet dies. going on. Anybody have any particular questions?
This is super helpful, Jason. I didn't know that trick for jumping around the file system. I was just going to say, I think your snippet to catch the ephemeral storage for a pod, it looks like it considers the whole pod, and we were only popping into the web service container. I just did a test where I jumped into Workhorse, and Serve GitLab was huge there too. So that's probably it.
Bingo. I was hoping somebody would realize that's the reason I couldn't account for the other disk. That's because Workhorse has its own separate content, right? So I pulled the entire pod and I chose something that I knew had more than one container in it. Because exactly, there's two containers, which means there's two file systems that may have changes written to them, whether they're logs or contents. Now, Workhorse doesn't use Bootsnap, but it does things, right? And that's exactly the right call. Thank you. Is ephemeral storage is an item in the API that takes the sum storage consumption by everything in that pod. So you may have to look and see, is there more than one container here? Did a sidecar get added to the pod? Did an extra container get added to the pod? Are they consuming things, right? We can set the resource requests on our containers, but if somebody, say, uses Istio and Istio for some reason starts consuming ephemeral storage, that's outside of our control. But the best we can do is provide, hey, go look for this.
Yeah.
Not every pod has one container, and as a result, we ecosystem.
Mm-hmm.
It brings up a question for me when other containers complete, will the node garbage collect the diffs when the containers exit, so other containers in the pod?
So this is the basic gist, is the overlay diff patterns will be removed when the container is stopped. Right. So that's up to the runtime itself. So if you go into that diff directory that is part of the overlay driver, it's specifically tied to that exact container instance. So if you stop the container as a whole, the runtime will stop the whole thing and rip the file system apart. It will start a new one. Otherwise, what you end up doing is effectively just trying to restart PID 1. And then your file system will be staring at you like, what? Now, should is being the key phrase here. I don't immediately have empirical evidence that tells me that is exactly how it behaves. So I would be wrong. And it's entirely possible that I have seen a report where somebody tried to restart just one part of the pod and then had a file system permissions error when they tried to rerun a template. That template got rendered into one of the volumes. So should nuke the diff layer. Will it or not? I'd have to prove it. Now, the interesting part is, does anybody know the command to specifically nuke just the one container? The answer is, the easiest way I can figure out how to do it that is not a specific command of kube control, go kill the one container in the pod, is to go into a node that you know it's on, hop in with sudo htop, find the process ID, and literally just pop that layer of PID1 and watch the container die. Or jump into the web service container inside of the web service pod and kill PID1. Because you are the user that started PID1 in that scenario, so you technically can. right? Force the pod to die on that container because of health check, right? It will try to restart that container. That's all I could do is empirically test what happens. I have caps lock on. Okay. Well, if anybody else has any other questions, raise them now, or I'm going to say that's some crickets. Well, then that is some crickets. Thanks for coming, folks. If you have further questions, feel free to follow up. Viewers of the later dates, I hope you made it this far. This is a fun one to trace down, and this is one of those challenges that distribution has to deal with. So, this is us arming you with some of the information and some of the tools to go digging around. Ask us questions, and we'll do our best to solve these. For us, we have two takeaways. One, Bootsnap is doing its thing, but it's expensive. And two, we need to start gauging that and setting ephemeral by default in all containers, at least for the request. So we have a research spike, and we have an action item to do for every chart. So the good news is they're small and they're straightforward. Downside is we need to collect the information first. All right, everybody. Thanks for coming, and we'll see you later.
Thanks, Jason.